I welcome you to this session on circular races. Since this is the first session on circular races, we will take a look at some basic concepts on which problems in circular races are based. So, in case of a circular race, we have people moving around a closed circuit or a circular race course, and generally there are two differences that we will come across when we solve problems on circular races. Number one, each person traveling passes every point on the racetrack again and again. That means if these two people, A and B, they move around this circular racetrack, then they will pass through this point S again and again. Now, this depends on the length of the track and the length of the race. Similarly, because they are moving around this closed circuit, A and B will either pass each other again and again, or they will cross each other again and again, or they will overtake each other again and again. So if they're running in the same direction, the faster person will overtake the slower person, and if they are running in opposite directions, they will cross each other again and again. So with this background, let us try to solve a few simple questions on the concept of circular races. So we have question number 1. A and B move around a circular path 400 meter in circumference at speeds of 20 meter per second and 25 meters per second in the same direction. After how much time will A and B return to the starting point together? Now, before we begin, let me tell you that there are only two very basic types of questions which are based on the concept of circular races. Number one, you are given the length of a racetrack. You are given speeds of people who run around the racetrack, and you are asked to find that if the two people start from point S, then at what time will they be together at point S. So this is the first type of question which is based on circular races, and let us see how to solve this. So when you carefully read the question, you will recognize that in this case we need to find out when A and B will be together at the starting point S. So because we need to find the time when they will be together at the starting point, our first step should be find the time required by A to travel one full circumference, and this must be equal to distance upon speed of A, and that is given by 400 divided by 20. So this is 20 seconds. Next, we need to find out the time required by B to travel full circumference. Again, this is distance divided by speed of B, which should be equal to 400 by 25, and that is equal to 16 seconds. So this is more like a question on LCM, finding the LCM of 16 and 20, because A will come back to the starting point after times which are multiples of 20, say 20, 40, 60, 80 and so on. And similarly, B will come back to the starting point after times which are multiples of 16, say 16, 32, 48, 64, 80 and so on. So the time after which A and B both come together at the starting point is given by the LCM of time required by A and time required by B, which is equal to LCM of 20, 16, and this can be easily calculated as 80 seconds. So A and B, if they are moving in the same direction, will come back to the starting point together after 80 seconds. In this question, if the question were that A travels in one direction and B travels in one direction, would it lead to a different answer? For this particular question, the answer will not be different, because we are required to calculate the time taken by A to travel one circumference and time taken by B to travel one circumference. The time to travel one circumference does not depend on the direction, and therefore the answer to the question, if the directions of A and B were different, would also have been 80 seconds. Let us now look at another question, another similar question based on circular races. So we have A, B and C move around a circular path 400 meter in circumference at speeds of 20, 25 and 40 meter per second. Find after how much time will the three A, B and C be at the starting point together if A and B move in the clockwise direction and C moves in anti-clockwise direction. So let us try to solve this question first. So we have a circular racetrack, and on this racetrack we have two people A and B who move in the clockwise direction, and we have a third person C who moves in the anti-clockwise direction. Now you are required to find that if all of them start from this point S, when will they come together at S again for the first time? Again, we need to find out individually after what time will A, B and C reach the point S. And to do that, we can find the time required by A to come back to point S again as the distance divided by speed of A, which is nothing but 400 divided by 20, and that gives us 20 seconds. Next we have the time taken to travel the circumference by B. This is equal to distance upon speed of B, which is nothing but 400 divided by 25, and that gives us 16 seconds. And although C is moving in a different direction, we still should understand that he will come back to the starting point after an interval which must be equal to the distance divided by the speed of C. In this case, the distance is again the circumference, which is equal to 400 divided by 40, and that gives us 10 seconds. So after what intervals will A come back to the starting point? If you calculate the intervals after which A will come back to the starting points, it will be 20, 40, 60, 80 and so on. Similarly for B, it will be 16, 32, 48 and so on. Similarly for C, it will be 10, 20, 30 and so on. So because they come back to the starting point after intervals which are multiples of their times required to travel one circumference, our required answer should be given by LCM of time required by A to travel one circumference, time required by B to travel one circumference, and time required by C to travel one circumference, which is equal to LCM of 20, 16 and 10. And this LCM is once again 80 seconds. So despite the fact that C is traveling in opposite direction, we will use the same method as we used in the previous question to calculate our answer, and our answer in this case is yet again 80 seconds. So with this, we come to an end of this particular session on circular races. If you have any doubts, or if you have any queries, or if you want to attempt more questions, please log on to our website www.pfindia.com. In case you have any queries or doubts, you're also welcome to write to us at studentservices@pfindia.com. And if you're watching this video on our website, please use Ask a Doubt feature to ask your doubts. Thank you very much.